Hi, my name is Jaden Vorzart and this is Australian Agriculture and Greenhouse Gas Emissions. Delving into curriculum links, learnings on the topic directly relate to the Australian curriculum's geography knowledge and understanding, as well as cross-curriculum priorities around sustainability and environmental management. The topic also appeals to the Victorian State Curriculum's Science as a Human Endeavour, looking at the importance of wider research into fields like greenhouse gas emissions and how farm and environmental management techniques can be influenced by this research. First, let's learn about the significance of greenhouse gases. Every day, solar energy is radiated through our atmosphere and onto the Earth. A third of this energy is reflected back out to space by the atmosphere and the Earth's surface. Then the rest of the energy is absorbed by the Earth as heat, which all life needs in some way to function. But what keeps all the heat from escaping out to space? Answer: greenhouse gases, predominantly carbon dioxide, methane, and nitrous oxide. The atmosphere naturally has some of these greenhouse gases that allow the Earth to retain much of its heat, which is good. However, since the Industrial Revolution, humankind has accelerated the production of these greenhouse gases, which has increased the Earth's ability to retain solar energy, effectively creating a blanket of gases over the Earth that traps in heat and changes our climate. This is termed the anthropogenic, or human-driven, greenhouse effect. As humanity becomes increasingly industrialised, greenhouse gas emissions will continuously increase unless we take action to reduce emissions. In 2023, agricultural production accounted for 17.5% of Australia's national greenhouse gas emissions. This is significant, considering agriculture only accounts for 3% of Australia's annual production of GDP. We should try to reduce these emissions, but first we need to understand where they come from. The most commonly produced greenhouse gas is carbon dioxide, which contributes around 70% of Australia's total greenhouse gas emissions. The consumption of fossil fuels to power vehicles and machines releases carbon dioxide. This occurs through tractor work, transportation of goods, and powering general farm facilities. The second most produced gas is methane, which contributes to 24% of Australia's total greenhouse gas emissions. This gas is commonly produced as a byproduct of ruminant digestion. In other words, methane is emitted through the burps of livestock with 4 stomachs, including cows, sheep, and goats. The final significant greenhouse gas is nitrous oxide, where emissions contribute 4% of Australia's total greenhouse gas emissions. Normally, soil microbiota and bacteria facilitate the transformation of nitrogen into different chemical forms through the process of nitrification and denitrification, so that plants may utilise nitrogen for growth. But when there is an over-application of nitrogen fertiliser, there are often insufficient microbes and bacteria available to complete these transformative processes. When incomplete, nitrogen is volatilised or converted from solid to gas and is more readily converted into nitrous oxide, the greenhouse gas. Farmers can change their production practices to be able to mitigate or make less severe greenhouse gas emissions. Joining us today is Kirrilly Loveday, agricultural scientist, to talk to us about mitigations of greenhouse gases on farm. Kiri, how can we reduce on-farm carbon dioxide emissions?
Switching to renewable energy sources instead of a petrol pump, using a solar pump, or use electric quad bikes instead of petrol or diesel quad bikes. Or on any infrastructure and shedding, such as your dairy, use lots of solar panels and a solar battery storage.
What options are available to farmers wanting to reduce their ruminant methane emissions?
Some emerging technologies in feed additives, such as Asparagopsis, a seaweed that produces a bromoform that prevents the production of methane by inhibiting an enzyme in the gut when they're digesting their feed. They're still emerging technologies and there's not too much uptake on farms yet, but that could be changed with greater government intervention.
What would you suggest a farmer do to reduce their nitrous oxide emissions?
A farmer could reduce their application of nitrogen fertiliser and instead use other sources such as chook manure, and then when they're using nitrogen fertilisers, follow the 4R principles, which is the right rate, the right product, the right timing, and the right place. Can also utilise the source of nitrogen fixing plants such as clover or lucerne.
Thank you, Kiri. Here's an overview of what we've learnt today. Thanks for listening, everyone.